So this study is in response to direct feedback from producers looking for non-chemical methods of control. And this is a desirable thing because the standard treatment for cheatgrass right now is herbicide application, and herbicides can be expensive. So if producers can use the livestock they already have and save some money on herbicides, that would be ideal. So that being said, there's not much in the way of controlled studies looking at the effectiveness of targeted grazing or comparing it to herbicide treatments, which is important if you're a producer and you're deciding which method you want to go with to know which might be the more effective method or which might be more efficient to use. So for any of you who are not familiar with cheatgrass, I want to touch on what it is for a minute. It's an invasive winter annual grass and probably one of the most widespread weeds in the western U.S., and it causes a number of problems on our rangelands. So it can be a good forage in the spring, early spring, but there's a very short window in which to graze it. And once it matures and dries out, it can be damaging to livestock. The pointy seeds can cause lump jaw, but at that point, a lot of animals won't touch it anyway. So it's not quite as good a forage as our native perennial grasses. It has a really rapid life cycle. As a winter annual, it'll germinate in the fall and then overwinter and continue vegetative growth rapidly in the spring. And this allows it to outcompete our native perennial grasses. It kind of gets a jump start. And it's also results in a close relationship to wildfire. So because it matures and dries out quickly, as I mentioned, there's a lot of fine fuel buildup and it's easy for fires to spark. And so it tends to increase fire frequency. And then in turn, cheatgrass is really good at taking advantage of the open spaces and excess nitrogen left behind by fire. So it kind of results in a nasty cycle. This is also a problem for sage-grouse and other wildlife that are dependent on sagebrush. If you have a sagebrush system and cheatgrass moves in and you get a fire running through there, the sagebrush is not going to bounce back very quickly, and it's going to allow cheatgrass an opportunity to move in and take over. So causes problems for wildlife as well. And these are all reasons why it's really important to control cheatgrass. So that all being said, once again, the objective of this study in a nutshell is to evaluate the effectiveness of multi-species targeted grazing for cheatgrass control using sheep and cattle and comparing it to herbicide treatments. So to do this, we set up our study as a randomized block design, and we have 12 different treatments, including a check, and 3 replicates. So we have 3 blocks set up out here, and I do have a little handout that you guys can pass around because I'm not sure if I have enough for everybody. That's just kind of like an aerial view of what you're looking at out here. So we set it up with the 3 blocks is to account for a variation in species composition. So I think it might be block 2 that has a little more knapweed in it. And so each one of the blocks has our 12 treatments. And our 12 treatments include cattle grazing in the spring, in the fall, and then in the spring and fall, sheep grazing in the spring, fall, spring and fall, and then a mix of our cattle and sheep in the spring, the fall, and the spring and the fall. And then we have our 2 herbicide treatments, which are Plateau at 6 ounces per acre and Matrix at 3 ounces per acre applied pre-emergent in the fall. And then our check, so that we have something to compare it all to. And each grazing cell that we have is 30 by 60 feet, so it's about 4% of an acre. And for the different treatments, for sheep alone, we used 20 sheep. For cows alone, we used 4 cows. And then for our mixed treatment, we just halved those numbers. So it's 10 cows and 10 sheep and 2 cows. And that all works out to a stocking density of about 100 animal units per acre. So I want to talk a little bit about our setup out here. For the perimeter, we have permanent electric fence, and also in the gates and aisles. And then inside, to separate out each grazing cell, we have temporary electric fences. That's the white kind of mesh over there. And those are movable. And so having the gates and the aisles or having the center aisle is nice because it makes it easy to move the animals from one cell to the other. When they're done grazing with one cell, we can just move them into the aisle and then move the electric fences to the next cell. So it took a lot of time and energy to get the permanent fence set up and even to figure out some of the temporary fencing. So hopefully this will be useful in the future once this study is done. For anybody interested in doing further grazing studies, this will be a nice resource. This study is fairly new, so we only have done one treatment, and it's this past spring we did a grazing treatment, 2013. We had sheep. For the sheep, we had a herd of white and black-faced ewes, and they were brought in first to graze, and then they were followed by cow-calf pairs. And we grazed them separately so that they wouldn't spook each other. Although we did have an occasion where one cow decided to jump ship and 3 or 4 of her friends decided to follow, and they each took their turn like jumping in with the sheep in their grazing cell and then jumping into another grazing cell, and the sheep handled it pretty well. They just kind of like huddled up in a corner and waited and then did their thing. But that was an interesting day. We collected pre-treatment data, so we used Daubenmeier to determine percent cover of species within plots, and we also took plot level pictures. And I'll pass these out now as well. I have a little handout of the pictures that were taken post-grazing and post-sheep grazing anyway. So the picture on the right is, actually you guys can just, that might be enough there for everybody to have one. So the picture on the right there is ungrazed, and the picture on the left was grazed by sheep. And then the second picture is one grazed by sheep. We were aiming for 90% utilization. So our original thought was to leave the single species treatment in for as long as it took to achieve the 90% utilization, and then the animals in the mixed species treatments would stay in for the same amount of time. So for example, we had 20 sheep in the single species, 10 in the mixed, and once the 20 sheep hit their 90% utilization, then we would remove all the animals, and the idea there was that theoretically the 10 sheep would have only grazed half as much. Although the sheep grazed really well, so there were some cases where it almost seemed like the 10 sheep did as much as the 20 sheep. The strategy didn't work out so well for the cattle. It was more a matter of just leaving them in there for as long as it took them to eat something. They didn't graze so well this last spring. The sheep, it was kind of interesting. The first day we put them in, we had them in a couple grazing cells, and then we moved them to cells with knapweed, which is one of the weeds I mentioned earlier, and we can go down and take a look later. They didn't touch it on the first day, and then the second day we put them back in those cells to get some more utilization, and they just kind of went at that knapweed and mowed it down. So there's a really good example down there, kind of a fence line that we can look at in just a minute. So we also took pictures right after grazing, which is what I just showed you, and collected cover data again in July to get some midsummer data that we could analyze. And so we kind of found out, analyzing that data, what we expected. We didn't see any significant change from one grazing treatment in terms of percent cover, which we didn't really expect to see anything after just one treatment. So in the future, we'll have grazing treatments again this fall, and then apply herbicides this fall as well. And next year, we'll most likely clip plots to determine biomass and evaluate seed production. And so we may be able to see more with those two measurements than with just percent cover. Seed production in particular is going to be really important because that's the ultimate goal with all of these treatments, is to reduce the cheatgrass population by reducing the seed production. And most likely this will be a long-term study. It's just speculation, but I doubt we'll see much, maybe within 1 or 2 years, but I might be surprised. But my thought is it'll be a long-term study. So that's all that I have. So if you guys have any questions or you want to go down and take a look, yeah.
Go ahead. Regarding your sheep, it sounds like a little training on the cheatgrass might get them to come back and want to eat that a little more readily. You're going to use the same ewes?
I'm not actually sure if would like to use the same ewes because they actually graze the cheatgrass really well. I mean, as soon as we put them in there, they they were eating it. So hopefully we can get the same ones back. But
what was the time period? Did you actually time the livestock?
we did, yeah. So the sheep were in there for anywhere from 2.5 to 3 hours. That's about as long as it took for them to get that 90% utilization. The cows we timed, but like I said, they didn't graze very well. We had them in there pretty much all day at one point, and they just really, there's a few theories for why that might be, but they just really didn't graze much. So, yeah. Yeah. Any other questions, or would you guys want to go take a look at some of the plots? Alrighty. So there's signs for each of the different cells that tell what the treatment was and when it happened. And so we didn't, like I said, we've just had the first spring grazing treatment. We haven't had any fall treatments yet. So if you guys just want to walk down and take a look, you're welcome to. I might go down and stand by the one knapweed. I'll point that one out for you guys. Oh, and I will need the handouts back.
Did you have a lot of cheatgrass in here before you started?
We did, yes. I should have brought pictures of what it looked like before we started, but there was quite a bit in here. So thank you. But yeah, if you want to just take a look, and like I said, I'll show you where the knapweed applies.
When does cheatgrass start growing? When you said it starts in the fall?
It yes, it germinates in the fall, and then will overwinter, and then finishes out growth early spring. It can germinate again in the spring with like good moisture.
What will you see in the fall? Is there anything? Can you tell, or?
It's kind of hard to tell. It'll just be like little. Yeah, and that's like later. I'm guessing October, November would be when it would probably germinate.
I assume the charges are turned off, right?
Yes, the charge, it's not charged right now. Good question.
I look over there and I see it on the post and I'm thinking, oh, it's still hooked up.
Yeah, yeah.
Your friend's hand.
That's right, yeah. And I think it's 112 where you can see a really good distinction of between the knapweed that was grazed and ungrazed. Oh, I'm sorry, 112 doesn't make sense. It's down here on the left. Yeah. Nope, this one was not treated yet. So the herbicide application will start this fall.
So you're just getting started here.
Yeah, it's really early on. So yeah. But yeah, let's see, 112 is down this way. So this is the one, you can kind of see the knapweed is all that darker growth in there. And I think I'm at the right one. So it's between the two posts out there, and you can kind of see, particularly with this cell over here, the difference. They kind of took out that knapweed, which wasn't our target weed, where, you know, hopefully we'll find out more about cheatgrass more, but visually it's easier to see the knapweed right now.
You may learn something else in the process.
Yeah, absolutely. That'd be nice. Mm-hmm.
So I see at that point down there, I don't see any more knapweed.
Nope, and that's where the blocking kind of helps. So, well, this is partly in block 1 too, but block 2 I think has, I guess they both kind of have a lot of it, but
Yeah, some heavy knapweed from there to there.
yeah, so block 1 and 2, that's where we'll have the treatments replicated 3 different times in the 3 different blocks. So, so for example, block 1 and 2 will have the knapweed, and block 3 really, I don't think has much knapweed at all, if any. And so we'll be able to kind of account for that variation and see if it's making a difference or not. But yeah.
So hopefully somebody's also looking at your knapweed control too.
Yeah, yeah. Yep, I'm not sure if we'll be able to evaluate that yet, but we'll see. It'd be interesting.
Cattle probably just mostly stomp it down, huh?
What am I looking at here? I'm not. plant guy, so this here's the,
This here's kochia, the green. The knapweed is like the darker, so
this
it's
stuff
kind of
right in here.
dead right now. This is actually a tansy mustard, but let me see if I can. Oh, here, yeah, yeah, that's a good one right here.
oh,
So
I
this
see.
is your
Got the
knapweed.
heads on it.
That's naturally green.
Yep,
Right there's one that's not completely brown.
yep.
It's a purple flower when it's flowering. So your cheatgrass is just laying on the, this has been trumped down, right?
Yes, well, let's see, what is this treatment? It might just be, so this was a, sorry, I need to look real quick and see what, thanks. Okay, these were actually both herbicide treatments, so that might just be from moisture, rain. So there were no animals in here. But yeah, you can kind of see, here's an example of some cheatgrass over here. So this kind of grass right here is your cheatgrass. And so you'll see it. There's some areas where, thank you, where we have some good, you can kind of look at fence line and see where there's some cheatgrass where it's been, where it hasn't been grazed and some where it has. So, yeah.